Hey there everyone, welcome back to a quick little video. After the last video I made on the EcoSimmer electric kettle thing, cooking stove for backpacking, I ended up kind of diving down the pathway of electric versus gas comparisons and was going to do a whole little series on like cars, bicycles, scooters and all that stuff. And I realized that's kind of doing the same thing like 20 times and I'd rather not do that. So instead, I built a calculator so you can do that for yourself. So I wanted to make a little video on how to use the calculator and what I've built so you can see how to use it and also how to access it. So let's get into that. So to get started, first thing we got is this online calculator page. This is at hopalonger.github.io/CO2 calculator. I'll put a link to that in the video description and you can access that through the link. It's not too hard, and it brings you to this page. It's not the best looking page, I know that. I'm not a great web developer, I'm sorry, but it is a web page and it does work, and that's the most important thing. It's also really easy to run. You can download all the files, see the code, and see the math. You also get a little explanation point section down here and all of our sources we use. What it does is allows you to enter your miles per gallon for a conventional vehicle. So in this case, you might use a car, and 35 miles per gallon is the default that it comes with. That's, pretty good car. My car does not get that, but that's a good baseline. And then it allows you to check your fuel type. You want to say it's like a diesel car, say you get a propane car. Those are our main three fuel types for cars. I don't have anything for premium versus, regular versus, E50 or E95 like racing fuel, but it's good enough. Then it allows you to compare to electric vehicle. I left it in this electric vehicle state because I want to allow people to switch between not just cars and other things, but like compare a car, an EV car, to a gas or EV bicycle to a gas car, or an EV scooter to a gas car, because those are different use cases people might actually be using. Um, like for instance, I actually bike to work. I don't drive, and people might be like, well, I could drive to work, or I can pick up this $3,000 EV bike that's in my budget and actually see how much that result of a difference is, and if it's worth that difference. Or a car, is it actually worth going and buying a whole nother car, or is it worth just keeping your old car for a few thousand more miles, kind of thing. So the four input fields we have is our battery size and watt hours. A lot of times you'll see watt hours rated on an item. It's gonna be in pretty small print, just kind of somewhere on it. I don't have a good example of something that says it. I'll find one that says it, like shows the little panel. It's gonna say watt hours. It might also say kilowatt hours, which is 1,000 watt hours. So like a Tesla PD100 has 100 kilowatt hours or 100,000 watt hours. Um, the number of charging for battery replacement, this is going to vary based off of the vehicle you're driving. I leave this at 400 as a default for the website. This is a standard for lithium-ion batteries, before they start to degrade to the point where they should be replaced. Your electric scooters, your electric bikes might have a bit higher as they use better batteries and different charging system, but your things like your phone and whatnot might actually truly at 400% need to be replaced. It depends on the battery chemistry. I highly recommend you check out our sources on this from this battery page to learn more about battery cycles and how they're affected based off charging cycles. There's a lot of chemistry that goes in it, but 400 is a good number for a low-cost electric vehicle. From the number of miles per charge, it's simply if I hop in my charged up 100% vehicle, how far can I go? Once you got that, you put it in there. And then we also have kilograms of CO2 per kilowatt of energy produced. This is based off of an EPA figure for how much the grid averages. That's what the default is. But say you have solar, say you have a renewable energy source that you know is going to be powering your thing. So you're really cool, really like the environment. You bought a solar panel, and you're going to use it to charge your electric scooter all the time. Then you can put in like zero carbon from that. Or you can leave it as default if you're just using the average American power grid. Or if you want to, you can look out for your power grid, or some power grids like mine allow for us to pay extra per kilowatt to have it come from renewable energy sources where we can have peace of mind that the CO2 figure might be much, much less, like 0.2 or even 0. So now that we have that, let's do a little example. So let's say we're comparing to my car, which gets 20 miles per gallon. I drive a big old car. It happens. I'm sorry. And let's say we're gonna look at an electric scooter. So let's just find the best electric scooter. Okay, I found a scooter and I pulled up its tech specs. This is some random Highboy 2S Pro electric scooter for commuting. It's not a great scooter, but it's a scooter, and that's what counts. So in the tech specs, we have all this information. Most of this isn't really super relevant to us, but one things we will need: max range, 25 miles. If you got a scooter that you own or a vehicle you own, I recommend putting what your realistic actual range and what you're getting is. So for this case, I'm gonna actually say 20 miles because 25 is probably pretty optimistic and it's market material, you know. We're gonna leave the batteries or charging before replacement 400. It's a pretty cheap electric scooter, so I'm not expecting them to have any special batteries or anything that might make that number bigger. Then battery, it says 36 volt, 11.64 or 6 amp hour battery with lithium ion, and that's not in watt hours. So one thing we can see down here is how to find the battery size information. So what we can do is we can calculate that by multiplying, take our watt hours and get that from 36 volts times 11.6 amps, which if we do that really quickly, 36 times 11.6 comes out to 417.6 watt hours. 417.6 watt hours. Boom. Now if we hit the calculate button, look at that. It'll tell us exactly how many kilograms of CO2 are produced per mile driven for both the gas vehicle and electric vehicle. Very, very big difference in this case. There's sometimes, if you're driving certain vehicles, where that difference won't be much because the batteries have a ton of stuff in them. I'm working on creating a calculator that actually goes just through raw energy consumption, but for now we're going to start with vehicles and I'll make some more changes later. Another thing to note for this calculator is it does also have the option for us to convert units. So it'll actually change it for, instead of number of miles per charge, it'll be kilowatts per charge. And then once we hit result, generate, it comes out to be slightly different numbers because it's per kilometer, not per mile, which is, you know, great to see. If we go back, it does still keep things in kilograms for this case. I don't have it convert to pounds because, well, I like kilograms. It's a more useful measurement, and you're still comparing the scale, which I think the main thing is knowing, whoa, if I drive my scooter, it is 20 times less CO2 per mile than if I drive my car. That's a really, really big difference, and this allows you to quantify that really easily. There's not much else to it, but I got these little important notes section at the very bottom that allows for you to figure out what this is good for. This should not be used to compare, like, oh, I can get this gas car or I can buy this electric car, because this calculator is designed in the assumption that you already own a gas vehicle and you want to maybe purchase an additional electric one and not compare them directly, because they don't compare the manufacturing process for the rest of the vehicle and what environmental impacts that has, which might actually make the electric vehicle even better, or in some cases even worse depending on the vehicle. And that's a very big systematic problem that I haven't been able to come up with a good way to calculate and solve without doing lots of manual calculations, data collection on my own. There's also many other factors to take into account, such as energy generation systems, and just also the electric vehicle and support infrastructure that it has, and many other aspects like that that this calculator cannot quantify. But this is meant to be a jumping point to look at, to research and how you can see your impact of switching from electric or gas to electric or vice versa, and see what the difference is for what you're doing in your life. Yeah. That's kind of all I got for this little calculator and video. Let me know if you like this video, if you want to see more calculators, tools like this that I build. I'll make sure to link all this in the description. If you like this video, please leave a comment, ask some questions. I'll do my best to add features and whatnot. Feel free to make comments, pull requests, all the things on GitHub. I'll do my best to keep this updated as time goes on so that you can continue to use it. If you like this video and want to see more like it, please subscribe to my channel. I'm going to continue to make videos about once a week, if not even more often. Yeah. Thanks for watching, and I'll see you guys in the next one.